Lesson 6.1 is about the polygon angle sum theorems, and your learning goal is to be able to find the sums of the measures of the exterior and interior angles of any polygon. So we've got two big theorems that you're going to want to pause and jot down, and it's about the polygon interior angle sum theorem. And it just means that the sum of the measures of the interior angles of a convex n-gon is 180 times n minus 2. where n represents the number of sides. We might be unfamiliar with that word convex, and I'm going to zoom out to my notes. It really just means that all the interior angles are less than 180, but they're not necessarily all equal. So just any figure pretty much is a convex n-gon as long as they're all less than 180, and that's what we're going to be assuming right now. The corollary to this theorem, and corollary just kind of means it's connected to, like it's not really its own theorem, but it's part of the other one, is the measure of the interior angles of a regular n-gon is 180 times n minus 2 minus n, divided by n. And regular is just going to mean that all of the sides and the angles are the same. It's still convex, because they're still less than 180. It's just special because they're all congruent. So look at this pentagon we have here. It is a regular polygon because all sides and angles are the same, which is how we can find the measure of all those angles by dividing by the number of sides. So let's use those two formulas in practice. The first example we're going to do is 2a. And it says, what is the interior angle sum of a 17-gon? So let's decipher that question. It's first just asking us, what is the sum of the interior angles? And that is what we have a formula for. It is 180 times n minus 2. So we know that the sum is equal to 180 times n minus 2, where n is the number of sides. So let's substitute that in. It was 17, and if you do that math, 17 minus 2 is 15. Multiply that by 180, and the sum of the interior angles is 2,700. Now, part B is a little bit more involved, and it says each angle of a regular, that's important, that regular tells us that all of the angle measures are the same. Each angle measures 172.8 degrees, and it wants to know how many sides does it have. So let's go back up to that formula that tells us how to find the measure of the angles of a regular n-gon is 180 times n minus 2 over n. So the measure of the angles equals 180 times n minus 2 over n. Now in this example, we do know that the angles all measure 172.8, so I can substitute that. But what we don't know is how many sides it has. So if I'm setting this up, it's going to be 172.8 equals 180 times n minus 2 over n. And then we need to use our solving equation skills to solve this. So I can multiply by n on both sides to undo that fraction. And I end up with 172.8 n equals 180 times n minus 2. You can do two things here. You could distribute that 180, or since it's the only thing on that side and it's being multiplied, we can divide by it. So I'm going to show you guys that way. You can divide both sides by 180. And 172 divided by 180 is 0.96 n equals, and now all that's left is that n minus 2. Okay, so let's combine our like terms and subtract n from both sides, which is 1. So that is 0.96 minus 1 is negative 0.04 n equals negative 2. Don't be confused by these decimals and these negatives. Just keep solving like you know how to. We divide both sides by negative 0.04, divide by negative 0.04, and n is going to equal, when you divide negative 2 by negative 0.04, is 50. So that means that a polygon with 50 sides, that is so many, has an all have an interior angle of 172.8. Let's keep going with another theorem. Pause and jot down the polygon exterior angle sum theorem. This theorem talks about how the sum of the measures of the exterior angles from any convex polygon is 360 degrees. So it means that no matter how many sides this polygon has, if you were to continue a line segment out from each segment, just like how this theorem is showing you in its depiction, if the line segments were to keep going, all of those exterior angles that are labeled here, 1, 2, 3, 4, and 5, they add up to be 360 degrees. So the outside adds up to be 360 degrees. That's the big idea. So now let's use that information to find an exterior angle measure. Look at this figure here. Pause and think about it. And let's see what the information gives us. It says, suppose angle 1 is congruent to angle 3. That's what that little symbol means. So I know 1 is congruent to 3. And the measure of angle 1 is 3x degrees. So this is 3x degrees, which means 3 is also 3x degrees. The measure of angle 2 is 2x degrees. What is the measure of each exterior angle? If we want to find each exterior angle, we're going to have to use the fact that we know that they all add up to be 360 degrees. So in shorthand, the measure of angle 1 plus the measure of angle 2 plus 3 plus 4 plus 5 has to equal 360. Okay, that is in my way, so I'm going to erase it even though I know I just did it. Well, look at angle 4 and 5, and what do we know about those angles? If these are right angles and they form a straight line, what does angle 4 and 5 have to be? They also have to be right angles of 90 degrees. So if we're really adding these up, we know that we have angles 1, 2, and 3. So we have 3x plus 2x plus 3x. And then 4 and 5 are both 90. Plus 90 plus 90 has to equal 360. Amazing. Let's combine like terms and simplify. 3x plus 2x plus 3x gives me 8x plus 180 equals 360. Go ahead and pause and solve that equation. You should end up with x equals 22.5. That tells us what the value of x is, but if we look at the actual question and double check, did we answer? What is the measure of each exterior angle? Oof, didn't answer the question. So you go ahead and pause through step 2 and use the value of x to determine the measure of each exterior angle. Remember, you already know that 4 and 5 are 90. All right, let's check it. 1, once you substitute x in, should have gotten 67.5. 2 should have been 45. And 3, surprise, is the same as 1 with 67.5. Our last example is to find the measures of interior angles. So that was about exterior angles. So let's think back to interior angles looking at this diagram we have here. And what did we learn about interior angles? The sum of them adds up to equal what? Look back to that theorem. We add up to equal 180 times n minus 2, where n is the number of sides. So let's first figure out what is our value of n. We have 1, 2, 3, 4, 5. Great. Oop, that is way too big. So we're going to equal 180 times 5 minus 2 when we add up all of the other sides. So, all the other angles, apologies. Let's add them up. I'll start here with 3x plus 4. So 3x plus 4 plus 7x minus 3. We know this because the word sum means to add them all up. 6x plus 12 plus, 90, nice, a number, plus 6x minus 3, run out of room, equals 180 times 5 minus 2. Okay, we now can go through and we can combine those like terms and those constant terms, and we should end up with 22x plus 100. Hopefully you pause to do that. 22x plus 100 equals 180 times 5 minus 2 is 180 times 3, which is 540. All right, go ahead, pause, solve that equation. X has a value of 20. So now, to actually know what the measure of the interior angles are, we can substitute the value of x into each interior angle measure. And you guys can pause to do that substitution. We should have angle measures of 117 degrees, 64, 137, and 132 as the unknown angles. All right, that is lesson 6.1. Make sure you have those theorems written down. You're going to use them a lot, and you're ready to go